Hello, listeners. Welcome back to the Cyber Mindset. We are Sam and Chloe. Grab a coffee and settle in with us because today we are doing something a little different. We are taking some pretty dense exam-level cybersecurity concepts and, trying to turn them into everyday safety habits.
Yeah, exactly. We're pulling straight from the CISSP official study guide today to decode two of the most notorious and honestly most easily confused web vulnerabilities out there.
Right, which are XSS, or cross-site scripting, and CSRF, which is cross-site request forgery. And our whole mission for this deep dive is to look at these attacks through the lens of trust.
Trust is really the operative word here. Because the entire architecture of the modern internet is basically built on this terrifying baseline logic where browsers and servers just blindly follow instructions.
Which is wild when you think about it. I like to frame this by imagining handing a toddler a written note that says, go to the kitchen, eat a cookie, and then smash the living room vase on the floor.
Right, and the toddler is absolutely going to do it.
Exactly. The toddler, which in this case is the browser or the server, doesn't question who wrote the note. They don't sit there and analyze if smashing the vase is a logical or safe thing to do. They just read the instructions and execute them blindly.
And that's exactly why security should never, ever depend on users behaving properly. Good software has to expect the unexpected. It has to handle invalid inputs gracefully instead of just crashing or running a hidden command.
So before we jump into the specific attacks, let's establish why the web is so vulnerable to this in the first place. It all comes down to input, right?
Yep. The web runs on applications, taking user input, processing it, and spitting out a result. Every time you type a search query or fill out a form, you're providing input.
And if developers don't properly validate what you type into that text box, the system might accidentally execute it as a command instead of just reading it as plain text.
Right. Which brings us to input validation. If we had to define it in one snappy sentence, it's just checking if the data matches the exact expected pattern before processing it.
Okay, so since we know systems blindly execute code, what actually happens when an attacker successfully slips our own malicious code into a website you already trust?
Well, that leads us directly into XSS, or cross-site scripting. The study guide defines XSS as an attack where malicious HTML or JavaScript is injected into an otherwise normal, vulnerable web page.
So it's basically turning a site you trust into a weapon against you.
Exactly. And the text highlights two main types. The first is reflected XSS. This is where the attacker embeds the malicious code right into a link.
So like a fake phishing link to First Bank, right?
Yep, a fake link to First Bank. When you click it, the web application takes that malicious script hidden in the URL and reflects it back to your browser.
And since it came from First Bank, your browser's like, oh, this is fine, and just executes it.
Precisely. It executes the script, and suddenly it's popping up a fake alert or quietly stealing your session password.
Wow, okay, so that's reflected XSS. What about the other one?
The second type is stored or persistent, XSS. This is where the attacker actually saves the malicious code on the server itself.
Right. The study guide has a great example for this using a message board. So say someone posts a completely harmless-looking message asking for public transit tips to see the Mets play at Citi Field.
Which sounds totally normal.
Yeah, totally benign. But they hide a little script T tag at the very bottom of the post. Because the forum doesn't validate the input, it saves that script directly to the database.
And this is where it gets nasty. Now, anyone who views that specific message board thread will have that script execute in their browser automatically. They don't even have to click a weird link.
To visualize this, I think of it like a highly secure, trusted corporate office building. You work there, so you implicitly trust the environment.
Right, it's your home turf.
Exactly. But an attacker, like a malicious visitor, slips in and pins a unique sticky note onto the community bulletin board in the break room. And the note says, mandatory IT update. Run this diagnostic program immediately.
Oh, that's a perfect way to look at it.
Because the building is trusted, when you, the user, read the note, you just follow the instructions right there in your own browser.
And that is the absolute core takeaway here. XSS exploits the trust the user have in the website. You feel safe because the URL says the right domain, but the actual code running is the attacker's.
Okay, so that's XSS attacking the user. But let's logically pivot here and flip the victim.
Let's do it.
If XSS uses a trusted site to attack the user, CSRF or Cross-Site Request Forgery, uses a trusted user to attack the site or the server.
Right. CSRF is an attack that forces an end user to execute unwanted actions on a web application where they're currently authenticated.
So if I'm logged into my online banking site in one tab and my session is active.
Exactly. You have an active session cookie, so in another tab, you're just, I don't know, browsing an online forum,
Yeah.
and an attacker has posted a hidden link there.
Uh-oh.
Yeah, clicking that hidden link sends a command back to your bank to, say, transfer $500 to the attacker.
And because my banking session is still active in the browser, the bank just accepts the command.
It does. The bank sees a mathematically verified, trusted user asking for a transaction. It has no idea the request was secretly triggered by a hidden tag on some random forum.
It's essentially like a pickpocket or prankster tricking a trusted bank teller.
Oh, I like that analogy.
Yeah, so imagine you walk into a physical bank, you show your ID to the teller, and you establish trust. You are fully authenticated.
Okay, I'm with you.
But while you're standing there, a prankster slips a forged withdrawal slip into your hand and bumps your elbow, causing you to slide that forged slip right across the counter to the teller.
And the teller just processes it.
Right. The teller sees you, the authenticated customer, handing them a slip, so they just blindly process the action on the server's end.
That is a great contrast to XSS. CSRF exploits the trust a remote site the server has in a user's system. It essentially rides on the coattails of an active, trusted session.
So we have sticky notes tricking our browsers and forged withdrawal slips tricking our servers. Now that we understand how these two work in opposite directions, how do we actually stop them in the real world?
Well, the architectural defense has to begin with input validation, which we touched on earlier.
Right, and the source material talks about two main ways to do this. Allow listing, which used to be called whitelisting, and block listing or blacklisting.
Allow listing is definitely the stronger approach. It dictates that the application will only accept data that strictly conforms to a predefined structure.
So if a field asks for a zip code, it demands exactly 5 numbers, and anything else gets rejected at the door.
Exactly. Block listing, on the other hand, accepts everything by default except for specific strings it knows are bad. It's essentially a game of whack-a-mole that you will eventually lose.
That makes sense. The text also mentions escaping meta characters. Can you break that down for us?
Yeah, so escaping is basically turning programmatic symbols into harmless text. Take the less than and greater than symbols, which are used for HTML tags.
Like the brackets around a scripty tag.
Exactly. If the server escapes those characters, it translates them so the browser doesn't interpret them as code. It just renders them visually as harmless text on the screen.
Okay, wait, I have a question though. If the browser is the environment executing the script, can't we just validate the input on the user's end right in the browser to save time?
Absolutely not. And the study guide is very firm on this. Input validation must always happen on the server side.
Really? Why is that?
Client-side checks, like right in the browser, are just for user convenience, like highlighting a box red if you forget an @ symbol. An attacker can easily bypass client-side checks using proxy tools before the data ever reaches the network.
Wow, okay, so the server is the true vault and has to do the checking. What about web application firewalls, or WAFs? The text mentions those acting as application layer guards.
Yes, WAFs are fantastic.
Yeah.
They perform deep packet inspection on actual HTTP traffic. They understand web semantics and can drop a malicious XSS payload before it even reaches the web server.
That's awesome for XSS, but what about CSRF? Since the input in a CSRF attack isn't actually malicious code, it's just a forged command.
Right, the WAF won't catch CSRF because the command itself looks legitimate.
Right.
To stop CSRF, you need secure tokens. It's known as the synchronizer token pattern.
How does that token work in practice?
Think of it as a secret handshake.
Hmm.
The server gives your browser a highly complex, randomized, and invisible token that is embedded directly into the forms on the web page.
So it's not stored in the browser's automatic cookie jar.
Exactly. So when an attacker tries to forge a request from another tab, they can't see or guess that randomized token. The server sees the missing token and rejects the forged request.
That is incredibly clever. So as we wrap this up, the golden rule to remember for exams or just real-world security is this. XSS is about tricking the user's browser with injected code.
And CSRF is about forging a request to trick the server while the user is already securely logged in.
It really leaves you with a profound sense of the sheer interconnected complexity of the modern web. I mean, every single click relies on this invisible chain of validation.
It really does. Just a single unescaped character can compromise a massive database.
It's wild. Think about the web apps and links you click today. Do you know who is actually executing that code? And is your session really as safe as you think?